Okay, hello everybody. Thanks so much for coming to Nerd Night and coming to my talk. So, Nerd Night, as we were just talking about, is you, the audience, are the speakers at Nerd Night. You don't have to talk about something that you do professionally. It just has to be something that you know more about than the average person. And of all the things that I know about, I think I am probably the worldwide top expert on the subject of FizzBuzz. I think I'm the #1 person who knows about this topic. Well, what is FizzBuzz? FizzBuzz is a programming challenge, a very simple programming challenge that would be at an entry-level interview. Do we have any computer programmers in the room? Okay. Some. You don't have to know anything about computer programming to understand and enjoy my talk. We will get into a little bit of computer programming, but don't get stressed out. The first rule of computer programming is avoid letting your brain say, "What the hell is that? I'm not a technical person. This is too much for me." Just avoid doing that for like 20 years and you can have a career in computer programming. So FizzBuzz, it's a very simple programming challenge that I wouldn't say that being able to do it shows proficiency so much as not being able to do it shows a lack of proficiency. And in particular, this is interesting if you're learning a new programming language and you're trying to say, do I know this language? Can I like do some basic stuff in this? Not like am I an expert, but like do I kind of get the gist? So FizzBuzz is a great thing to try to implement in a new programming language. FizzBuzz actually comes from this book. It's called FizzBuzz, 101 Spoken Numeracy Games. It's a game for children to teach them about numbers. I was gonna read the definition of FizzBuzz from this book, but it turns out that the version in this book is not the version used in the programming challenge. So we're gonna skip that, but interesting fact if you're wondering where FizzBuzz came from. So let's get into FizzBuzz. So what we're gonna do here is display the numbers from 1 to 100, except if the number is divisible by 3, don't display the number, say fizz. If the number is divisible by 5, don't say the number, say buzz. Does everybody understand the rules of FizzBuzz? No, not everybody does. Okay, well, we're going to get into it. So this table here could help me. We're going to start with 1, 2, fizz. Got to follow the rules of FizzBuzz. Okay, Mom? Steve? Buzz, right. Okay, now let's skip ahead because we only got 20 minutes. Okay, Mike, 14 just happened. What's the next in the sequence? FizzBuzz, yes, that is correct. Yes, it's a trick, it's a trick. Right, FizzBuzz is correct. Here, so I didn't tell you all the rules. And that's something I like to do when I'm doing this as an interview question for programmers. Did you just start writing the code without understanding the edge case of if it's divisible by 3 and divisible by 5? This is what I call a programmer's OR. If you ask a programmer, do you want to get pizza for dinner or tacos? What's a programmer say? Yes. Yeah, that's the programmer's interpretation of OR. If I told you when to say fizz and I told you when to say buzz, and both things are true, obviously you should say FizzBuzz. That's what a programmer would think about this, that's the correct thing to do. Let's get into a little FizzBuzz implementation. We're gonna implement it in C, the C programming language, because that is an old programming language. It was invented by Dennis Ritchie in 1969. This is a picture of Dennis Ritchie taken with the technology of the time. It's an old version of the Apple Pencil called the Pencil. C has things like looping and branching. It's basically kind of like a pocket calculator, but with a couple extra features. You can loop, which is say, do this a bunch of times. You can branch, which is do this sometimes and do this other thing sometimes. And if you add those things together, then you get some pretty powerful sorts of things that you can do. It also has indexing by 0, which means that when I'm counting people, like I'm counting the people here, I would probably say, you're 1, you're 2, you're 3. In C, you would say, you're 0, you're 1, you're 2. This is just something that they decided to do. And when Facebook was doing its hour of code program, when it was teaching children how to program, but they could only do 1 hour, they focused entirely on this thing of counting starting with 0. And I thought, I don't think Facebook understands what programming is about. That's just an artifact of these C people. Also, I want to say it's called C because it's the language they worked on after B, and they couldn't think of a better name. Also, at the time, computers were very hard to type on, so they wanted it to be short. So everything in C and also in the Unix operating system by the same people, like drops all the vowels because like computers were basically like typewriters. Originally, they actually were typewriters, like mechanical typewriters. Then they made electronic typewriters, then network typewriters. That's where printers come from. Then you had a keyboard and a printer, and you would type your program in, and the answer would print out. Then they put a screen on, and that saved you a lot of paper. And we're still acting like we're using typewriters. Also, when you would hit a key, it would go like ka-chunk. So it just wasn't very fast to type. So that's why it's got such a short name. So anyway, here's some C code. It's got a bunch of cruft in it that you just have to do because you're writing C code, doesn't matter. Let's get into the algorithm part, which is what I call the FizzBuzzer, the part that does the FizzBuzz. Okay, so here it is, the FizzBuzzer part of the C. First, we got a loop. I said C has loops. We're going to do this whole chunk of code inside the curly braces. We're going to do it 100 times, one for each number, because that's what we're doing with FizzBuzz, numbers 1 through 100. Then we got these different cases. Now, if we do any of these ifs, we're going to do one and we're going to stop. We're not going to do the next one, okay? So this first case, this is a fancy way of saying, is it evenly divisible by? The percent sign is like, let's do a division, throw out the answer, keep the remainder, and then see if the remainder was 0. The exclamation point is a weird C way of saying, is it 0? So first we say, is it divisible by 15? Why? Because it's 3 times 5. So if it's divisible by 15, it's divisible by both 3 and 5, which is the FizzBuzz case. Now, if we get to the next case, we know it wasn't divisible by both 3 and 5. So if it's divisible by 3, it's only divisible by 3, so we say fizz. If it's only divisible by 5, we say buzz. And if we hit none of these cases and we go all the way to the end, then we're going to print the number itself. You don't have to understand this C code. This C code, I did not write this. I specifically wanted something I could critique. So this is like from the internet. And I don't think it's great, but it does do the thing. It does do the FizzBuzz algorithm, so it is correct. So why do we care about aesthetics in code? That's what I want to talk about. Well, some of you may know about National Novel Writing Month. That's a month in November where you try to write a novel in 1 month. It's not easy. You got to write a lot of words every day. So I wrote a 50,200 word autobiographical novel about my journey with FizzBuzz. This is true, and it begins like this. It was a crisp autumn in the fall, it was a crisp autumn in 2012. And my friend Steve was in town. Steve is here. He's actually one of the speakers. And Mike is also here. We were at Mike's house at the beginning of the story. And we started just doing some FizzBuzz whiteboarding on the windows of Mike's house, as you do when you're with your good friends on a crisp autumn day. And Steve said some stuff that kind of blew my mind about the FizzBuzz. And here's what he said. What the heck is this 15 doing in here? Excuse my language, but what the friggin' heck is this 15 doing in here? Now, we know about divisible by 3. We know about divisible by 5. That's part of the problem statement. Why we put this 15? Now, we talked about it before. It's because 3 times 5 is 15, okay? That's clever. I don't like cleverness. Because that means we got to know that fact about 3 times 5. And we got to know that that's what we meant. We got to know like what we were thinking at the time that we wrote the code. Do you know who does not know what you were thinking when you wrote the code? You in the future, and also every other human. Because we don't live in your head, we don't know what you're thinking, okay? So don't do this. I don't like this at all. So I rewrote this. I took some liberties. I rewrote it in a lot of different ways. But the important thing is I separated out the 3 and the 5. This says, is it divisible by 3? Meaning, is the remainder when we divide by 3 equals 0? And, double ampersand, that's and in programming, in C at least, and is divisible by 5. Break that out, and I think that that's much nicer. Now, I need to emphasize something. These programs are the same in terms of what they output, exactly. And in fact, they may be the exact same when you run them, because C compilers, they don't just run the code, they do all this optimization to it. It may, in fact, replace my code on the right with the code on the left. I have no idea what the C compiler is doing. My code has 2 different division operations. Code on the left has 1 division. It might optimize that away from me. We don't really know what the code is doing. Now, if you try to optimize your code, if that's why you were clever, was so that you could do less divisions for a program that just does 100 numbers, then I would not want to hire you to work with me, because I would call that premature optimization. Let's see if it's slow first before we try to optimize it by making the code less easy to understand. So anyway, I rewrote this whole C program in what I think is more beautiful C. Doesn't matter if you understand it. I just, we could get into this, and if we were doing an interview, I'd probably tell you all about how you should always have curly braces, and this is the best I could do while keeping it on 1 slide. And so to me, the point here really is just that there's a reason that we care about aesthetics, in code, but I'm not sure what it is, but it matters to me. So Steve said something else that blew my mind. Why are there 2 3s and why are there 2 5s in this code? We mentioned 1 3 in the problem, we mentioned 1 5 in the problem, and we got them all over the place. This is redundant, and if there's one thing that you know about programmers, is that they hate being redundant. Now, how do you write this in C with only 1 3 and 1 5? I don't know. I leave that as an exercise to the reader, but it's not easy, because C just doesn't really let you write code like that. Why have more programming languages than 1? Here's some programming languages that I know. I've been told this is above average for the industry. I didn't learn all these for work. I learned all these because I can't stop myself from learning more programming languages and implementing FizzBuzz in them. I forgot to tell the programmers in the room ahead of time not to shout out the answers unless you're called upon, because we will get to them. So Alan Turing, he said that we can make a machine that can perform any computation, which means that this is called Turing completeness. To some extent, all programming languages are the same. When a new shiny programming language comes out promising you the world, it fundamentally cannot do anything that the other programming languages cannot do. That is what Alan Turing said, and he knew what he was talking about. So why have other programming languages? Well, there's a site called Rosetta Code, like the Rosetta Stone. They have hundreds of programming languages. They have hundreds of programming challenges, including FizzBuzz. For FizzBuzz, they have obviously over 100 different solutions in different languages. And what I noticed is that across all the different languages and all the different programs, and especially for FizzBuzz, there's one language that always has the shortest answer, and that is APL. And here is the APL answer for FizzBuzz from Rosetta Code. Can everybody see that in the back? Is that as self-explanatory? Next slide. No, but seriously, what is this garbage? What are all these symbols that I don't know? And more importantly, how'd they do it with only 1 3 and only 1 5? Well, I had to know the answer. I learned APL. This would give you the basics if you wanted to read this book. I understand how this code works. I can write FizzBuzz and APL. But then I thought, is this as far as we can go? Or could we learn a more obscure dialect of APL? Oh, wait, I think I'm skipping ahead. I forgot to tell you what APL is. APL was invented by Kenneth Iverson in 1966, 3 years before C. We could all be programming APL. That could be the world that we live in. And it's a new notation for math. And I'm not sure how we reconcile that with C being like this kind of like loops and branches over a pocket calculator sort of thing. Right. Oh, yeah. So the thing about APL is it's got these weird symbols. You got to have a special keyboard. Steve's dad was actually an APL programmer, had a special keyboard and everything. And There you go. And I thought, this is weird and I don't love it. But then I thought about it more. And I thought, actually, all the other programming languages just use the letters and the numbers, as do the complete works of Shakespeare. So maybe we can say everything we need, but maybe a few more symbols wouldn't be that bad. And maybe we just figure them out. So anyway, right, back to going more obscure. I found this language, BQN. Their motto is finally an APL for your flying saucer. These are all the different symbols that they use. They got even more symbols than APL. So obviously you can write a really short, really beautiful FizzBuzz in BQN. So I did. This is my FizzBuzz in BQN, which I'm sure we can all agree is the most beautiful. It's also the shortest one on all of Rosetta code. So I am the #1 FizzBuzz programmer. Officially. But would my obsession with FizzBuzz had ended there? But then I thought, well, this is the best FizzBuzz you can make in an existing programming language. What if we didn't limit ourselves to the reality and went into the world of our imagination? So here's a language I invented for writing FizzBuzz in called Neo-FizzBuzz. Now, the color here is not semantically meaningful because Steve is colorblind and the only person that will read my FizzBuzz implementation. So that's just to make it pop a little bit. Yeah, so I started down this road, and then I thought, well, this is probably the best I can do in a one-liner, but what if we made programming two-dimensional? What is that? Why don't we go in that direction? So then I got obsessed with two-dimensional programming and did this whole series of different programming languages that I would invent using this kind of grid system. Did a whole series. This is all done manually in a spreadsheet. It was not convenient at all. And I'll just jump to the end of my series. This is kind of what I ended up with on the grid stuff. And then I thought, well, this is all nice and good, but what if we did hexagonal grids? This didn't work out as well as I thought it was going to. I thought this was really going to crack the problem. Then I thought, okay, well, it's a pain to do this all manually. So I made a program where I could enter trees directly, trees of symbols. I got off of the weird symbols and started doing just like named functions because I kept having to explain what the symbols meant. And here you can kind of guess. Obviously, you don't know what any of these mean. I made them all up. But you can kind of look at them and kind of guess and save some time. And then I thought, well, do we really need even trees to represent code? So then I made up this symbol based on Venn diagrams. And this is based on constraint programming. So I basically say if you're in the set of things divisible by 3, then you start with fizz. If you're in the set of things divisible by 5, you end with buzz. That just implies that if you're both, that you're FizzBuzz. So it's all in there. And this uses some math symbology, which is cool because maybe if you know some of that math stuff, I don't have to explain it to you. So finally, I went back and I took this kind of concept and I boiled it down into this just using symbols from math, and I have the big rectangle there as a special kind of branch where I say, we can do the first thing, or the second thing, or both of the things, and if none of those fit, then we'll do the number itself, which is the identity function in math. So at this point, I'm just restating the problem to you as the solution, and imagining that this language that is very good at implementing FizzBuzz exists, because that's really, I think of myself as a conceptual artist that works in the meaning of technology, and that's really, what the ultimate programming language would be one in which you just express what your problem is, and that's the same as writing the answer. There's none of this artifice of all of these like steps and making all these kind of loops and branches and like things. And so my friend Will Cook, who is a great programming language theorist, once said that the future of programming is moving from the how to the what, and I think that is the direction I'm trying to move here. So that I think is probably the ultimate FizzBuzz. I thought that this would be the end of my FizzBuzz journey. Then when I was putting together this 20-minute long presentation on FizzBuzz, I thought, here's the thing, though, about all my FizzBuzz solutions. They're all visual. What if you have low vision or no vision? you can't experience my art. You don't know about FizzBuzz because you can't see my solutions. So I think the next frontier is going to be spoken word solutions to FizzBuzz, kind of a tasting menu solution to FizzBuzz. There's also proprioception. That's if I close my eyes and I move my limbs, I know where they are, even with my eyes closed. So we can do an interpretive dance version of FizzBuzz. And the reason this is important to me is because when you think about computation, which is a universal concept, what you're actually thinking about is the nature of the universe and humanity's place within it. It's the intersection of physics and psychology. And so to ponder FizzBuzz is to ponder the way that humanity is reflected in the nature of the universe. So everybody should be able to experience FizzBuzz. And so I'm glad I was able to share with you. Thank you. I think I went over time a little bit. Do we have time for questions or?
Yes, we have time for questions.
Yeah.
Absolutely.
What could you possibly want to know about FizzBuzz? Because this is the venue.
Oh, yeah. What does the sequence sound like if you convert the fizz and the buzz into like kicks and snares?
That's a great question. I don't know, but we're going to find out.
Yes. Checking questions on Twitch. No, let's
I see some hands.
go to the room.
First of all, great talk. Love
Thank
where
you.
you're going with all that. I find myself wondering, my conception of essentially where you're kind of going with this is, in many ways, with adding more characters, it seems you're almost just creating macros, and you're also increasing the entropy of the choices in each of the symbols. Wouldn't the most elegant FizzBuzz program actually be the one that says it in the most concise, lowest entropy way possible, actually?
Yeah, that's a great question. When you're measuring, so entropy is, like kind of the information holding capacity of something. And there's an interesting thing, there's a thing called Kolmogorov complexity, which is a measure of entropy, which is basically saying, for any problem, how long would the program be to solve this problem? And that tells you how complicated the problem is. And the thing with that sort of measurement is you can only measure programs people have actually written. We don't know what the ultimate program would be. But the weird thing is, because everything is Turing complete, in order to be universal and be able to solve any problem in a programming language, the difference in the size of implementations doesn't depend that much on the programming language. Now, we did show that APL programs are shorter than C programs, but like the kind of the ratio, like if you do a more complex problem in APL, it's going to be bigger, and if you do a more complex problem in C, it's going to be bigger. So if you take out kind of this constant factor between languages, doesn't matter what language you use in terms of the measuring the complexity of a problem. And that's because, well, I could make a language, and people have done this, it's called, it's like a form of code golfing, which is like trying to write code in the fewest strokes possible, like the fewest characters or whatever. People have made languages where it could be one character just does FizzBuzz, like F. You could put an F and it would be like, oh, you want FizzBuzz, bam. And it's optimized for just doing these programming language challenges. However, once you try to use it for other problems that they didn't put in their special set, it then becomes longer to do it in those languages because you got to work around all these little shortcuts they put in, and it turns out to end up being the same in the long run in any language. So yeah, so I would say I both agree with you and don't agree with you, depending on how we frame the question. It's interesting though. I'm gonna let Mickey do the selection of questioners.
Oh, right.
So I represent mathematicians, and BuzzFizz is equally valuable to FizzBuzz, yet all of your algorithms are FizzBuzz biased. How are we going to resolve this in our modern age?
Yeah, it's a great question, and what I will say is that in the original version from the book, it's a little different, and it's true that in the original version, BuzzFizz would be just as valid, and there's also a third option, Whiz, for prime numbers that doesn't even get brought up at all. So, yeah, fair point. Something to think about for sure.
Hi, I'm not a programmer at all, but I'm an architect, and I think the 3 and the 5 seem extremely arbitrary, and later your client will change their mind. And so how many solutions do you have where you define 3 and 5 at the beginning, and then later 3 and 5 are swappable for other numbers?
Oh, you're talking about generalized FizzBuzz. Yes.
Yeah.
That is, in fact, what you do to a programmer that just solved FizzBuzz, is you say, yeah, but how does this generalize? And then they got to write a more generalized version, and yeah, that's part of the interview challenge is under pressure. And yeah, the three actually comes from the original version of the book, but the 5 was not in there. Instead, what you would do, and this is actually a much harder programming challenge, is that you say fizz if it's evenly divisible by 3. You say buzz if it has a 3 in it. So 33 would be example of a fizz buzz. But 15 would be just a fizz because there's no 3 in it. So yeah, it is totally arbitrary. It's just what they picked in the book was the 3. The 5, I don't even know where the 5 comes from. It wasn't in the book. Somebody just, I guess, thought that's the next prime number.
All right. Fantastic. Thank you
All right,
so
thanks,
much.
everybody.
Big round of applause.